right, so here we are at the bottom of page 21 here, and we had just substituted in these two x terms, which when we added them would have gotten us back to 1x in here. And we are going to look for whether or not there is a GCF and whether this is in descending order. So I'm putting my finger over the x when I'm doing that because we don't want to think about that while we're factoring what's in the parentheses, but also don't forget about it. You know, you don't want to lose that x as you are going along. It is important in the final answer of things. So if I look at those four, they are in descending order, and there is no there's no common factor for all four terms. You know, again, if we looked at a couple of them, then we can get a GCF, but not for all four of them. So we are ready to go ahead and look at factoring by grouping. So I'm going to leave that x out there, and I am actually going to change these to a square bracket so that when I put these parentheses in, it is a little easier to see what is happening. So I am going to pair the first two terms and the last two terms. Notice that I did go from subtracting 4x, I changed it to adding the negative 4x, keeping that negative 4 with the x, the negative sign with the x. And when I hit this part, now we look. And for factoring by grouping, we look at those two. What is the common factor between those two? So there's a 5, and there's an x that we'll be able to factor out. And let me grab an additional piece of paper here. Going off the page. All right, so, and everything else, you know, we're focused inside those square brackets, but everything else in the problem does need to keep dropping down with what we're looking at. So we can pull a 5x out from those two terms. When I think about what times 5x would get me back to 10x squared, so that would be a 2x. And what times 5x would give me 5x, and that's going to be 1. So if I distribute that 5x back through, you should get back to those two individual terms. So if you don't, then you need to double check what your factoring is looking like. The second pair, we do notice that they are both even. So we definitely can pull out at least a 2. And then the question becomes, I'm also noticing that they're both negative. And so would it be helpful to pull out a negative 2? To answer that, look at the binomial that you came up with from the first pair. It is a positive 2x plus 1. So we're going to want to try to force this binomial that we get to match this. That's our whole goal in factoring by grouping. So if we pull out a negative 2, that will aid in that. So if I pull out negative 2, again, I'm going to stick that in parentheses just to kind of highlight that. And what would be left behind then is 2x plus 1. And now, yes, I've got the same, I have the same binomial here. Okay, so those two are the same item. Okay, still hanging on to that x outside of the parentheses there. And then, remember, we can pull that binomial, that 2x plus 1, because it's common to both of them. It is a factor. And then what's left over goes in the second set of parentheses. So 5x and minus 2. And then that is set equal to 0. Now those square brackets are not necessary. That was just to kind of focus in on what was happening inside there when I had all of these other parentheses going on. So this will, I can drop those and just call this x plus 2x plus 1 times 5x minus 2 equals 0. And here we have gotten to all of it factored out. I have just a bunch of things multiplied together, set equal to 0. And that's where I need to be to use the 0 product rule. So in this case, because we have 3 factors, we're going to have 3 little equations to solve. So either x equals 0, 2x plus 1 equals 0, or 5x minus 2 equals 0. And then we solve each of those. Of course, the x equals 0, that one's already solved. It's just x equals 0. Subtract 1 over here, and we'll get x is negative 1/2 from the middle equation. And then the final equation, we'll add 2 to both sides. So we will get x is positive 2/5 for that one. So we have 3 of these, and yeah, I've put them in boxes, but I really do need to check these back into the original equation. So remember, and I'm going to hop back over here, this is the original equation here. So this is what we've got to substitute those things in. So I'm going to write that down on my other page. So 10x cubed plus x squared equals 2x. I really want to use that specific equation and check those 3 possible answers. So x, 0, negative 1/2, and 2/5. That's what we are looking at. And we'll just go through and we will substitute each of those in and see if we get the same thing on both sides. Now, 0 is a really great one to have because when we plug 0 in here, we get 10 times 0 cubed plus 0 squared equals 2 times 0. Of course, all this stuff is just going to be 0, and that will be 0. So yes, x equals 0 is a solution to this equation. Now we put in the x equals negative 1/2. And I do recommend leaving it as a fraction for this. It will make your life a little bit easier. I know it feels like it won't in the short term, but it will. All right, and don't forget, again, that it is negative 1/2. All right, so the right-hand side of the equation is going to simplify to negative 1. And then we've got some work to do over here on the right. Okay, so negative 1/2 quantity squared, so that will just be positive 1/4. This one over here, we'll have 10 over 1 times, and then if I'm cubing this, so it's an odd exponent, so this will be a negative 1/8. Right, negative 1/2 times negative 1/2 times negative 1/2. So, look at that off to the side if you need to convince yourself as to why that is the case. And then we will divide things out here, leaving us with negative 5/4 plus 1/4, and does that equal negative 1? All right, well, negative 5/4 and positive 1/4, that's going to give us negative 4/4, which will simplify to negative 1. Okay, so we're 2 for 2 on our solutions. We do just need to check that 2/5 one in there. And quickly doing that. And then we will look at some additional examples on the following pages. All right, so 10 times 2/5 cubed. So 10 over 1. Remember, you can cube each of these because it's division in there. So we've got 8, and then this is 1/25. And then here we'd have 4/25. And we're checking to see, is that going to equal 4/5? Right, 2 times 2. Remember this, think about this being over 1, so 4/5 there. All right, so then we do some simplifying over here. We can divide a factor of 5 out here, so that would give us 16 over 25 plus 4 over 25, and is that equal to 4/5? So I do have a common denominator there, so that's handy, and that gives us 20 over 25, and is that equal to 4/5? And yeah, when I divide out that common factor of 5, it is. So all 3 answers check out. So all 3 of those would be answers to that original equation, 10x cubed plus x squared plus 2x. So it looks like it's going to be really complicated, and yes, there are a lot of steps, but really the only new thing is setting each of those factors equal to 0. As we've been working on factoring, so you're going to continue to practice factoring when you're solving these equations. Then just set each of those factors equal to 0 once you get a bunch of things multiplied together, set equal to 0. And then checking. Now, we've been checking, or you should have been checking. If you haven't been, now is the time to get into the habit of checking every single one of your answers. And yeah, you can use your calculator on these. Just be careful because, especially when we have fractional answers, it can be tricky to put them into the calculator properly so that you actually get the answer that you're supposed to. So be thinking about that. All right. So back to page 21 there. So we were finished that up, so we will flip over to page 22. And these first few is just identifying, okay? Are these linear, quadratic, or neither? So linear, it's going to be a first degree equation. Quadratic is a second degree equation, and then neither. So this is why it's really important for you to be able to identify what degree each of these equations will be. And for our purposes right now, neither is just, as long as it doesn't satisfy linear or quadratic, then it gets defaulted into the neither category. All right, so x has a power of 1, so my equation here is going to be linear. Here, my highest degree term is 2, so this will be quadratic. This one actually has a 3, so that will be neither. The cubic is what it would be when we talk about that later in classes further on, so in 100 and as we go further. But for our purposes right now, it's not linear, it's not quadratic, so it's neither. Next one, also quadratic, has that 2 as the highest power. Here we've got a 4, so that's going to fall into the neither category. And then x to the first power, so this is linear. Okay, so it's pretty straightforward there, just, being able to identify what the degree is and then name the type of equation based on that. All right. These next few are focusing in on what the new part is. So we're not having to do the factoring. We are just using the zero product rule. So it's already a bunch of things multiplied together equals 0. So we just set each of those equal to 0. And we solve those. X is positive 5 or x is negative 1. And then we should go back to our original equation and plug those in and double check them. Now, the nice thing about them being in factored form, you can see if you put negative 1 in here, well, negative 1 plus 1 is 0. Boom. And we know that this is going to be 0 equals 0. So for this one, it's not as necessary for you to go backwards and do that. I mean, you should quickly look at that, but it's not as labor intensive as it is in some of the further examples the example that we looked at just a moment ago. Okay, next one there on the right. So 3x minus 2 and 3x plus 2. It's already separate factors equals 0. So that one equals 0 or that one equals 0. And here we'll add 2 to both sides. So 3x equals 2. So x is 2/3. Or, and then over here we'll have 3x equals negative 2. And x is negative 2/3. Those would be the two possible solutions for that one. I am going to do this one with you, and then I'm going to leave the other two for you guys to do on your own. But this video is about to end, so I'm going to pause here before I get on to that one.